Hello everybody and welcome to an ATC Maths and Science tutorial video. Today we'll be discussing how to determine the equation of a cubic graph when we are given the coordinates of a turning point. Our approach in this example is to solve simultaneously. Now, as you will see as we read through this question, we're not given equation 1 and equation 2. The things that we need in order to solve simultaneously. So obviously we would have to create these equations 1 and 2 for ourselves. So let's read through this question. This question is from the November 2015 paper 1. Right? So given h of x is equal to minus x cubed plus ax squared plus bx, and g of x is equal to minus 12x. Now, the equation of the straight line is not really relevant to the question we're about to solve, but anyway, it's there. And then we're further given P and Q with coordinates 2 and 10 are the turning points of H. The graph of H passes through the origin. And we're very interested in the fact that we're given this coordinate 2 and 10. Now, if I happen to draw just a rough sketch of a cubic graph, it's a rough one, and let's say I focus on this coordinate, the turning point. Let's say I give it values a and b. Then what I must notice, in order to get equation 1, I'm going to the original equation, and if I substitute a for x, I can set it equal to b. X, y, taken from the coordinates. But if I go to the derivative, f prime of a, I would set this equal to 0. And that's how I would get my equation 2. You see, what we're expected to understand is the difference between f of x versus f prime of x. F of x stands for y. X being your input, y being your output. Whereas f prime represents the gradient at this point. So when I say f of a, it must be equal to b, which is y. But when I say f of a, f prime of a, why do I set it equal to 0? Because at this point, as you can see, the gradient at a turning point is 0. So that's how we typically get equation 1 and equation 2. Once we have the two equations, then we're going to solve simultaneously like we normally do, right? So here we're going to have our a value would be 2, our b value is 10. So let us into this equation, in this case h of x. Let's find equation 1. So to get equation 1, let's just firstly write down the equation h of x. So we have h of x is equal to minus x cubed plus ax squared plus bx. So h of 2, which would equal minus into 2 cubed plus a times 2 squared plus b times 2. We know h of 2 is 10 is equal to negative 8 plus 4a plus 2b dot 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 equation 1. Now to get equation 2, we're going to need the derivative. So h prime of x is equal to minus 3x squared plus 2ax plus b. Here, this would be equal to 0 when x is equal to 2, because the gradient is 0 at the turning point where x is equal to 2. So substituting 2 into the equation for x, we would end up with negative 12 plus 4a plus b, and this would be our equation 2. The easiest way to solve simultaneously here would be to say equation 1 minus equation 2 using the elimination method of solving simultaneously. So equation 1 minus equation 2. So 10 minus 0 is 10. Minus 8 minus 12 is 4. 4a minus 4a is 0. And 2b minus b is b. Taking the 4 across, 6 is equal to b. And as we will see in the question, that's exactly what we expected b to be equal to. Now that we have the value of b, we will take the value of b and substitute it into either equation 1 or equation 2 to solve for a. I'm going to substitute into equation 2, so I will write alongside sub in 2. So we have 0 is equal to minus 12 plus 4a plus 6. Simplifying, 0 is equal to minus 6 plus 4a. Take the 6 across. Positive 6 is equal to 4a. Therefore, a is equal to 6 over 4, which is 3 over 2. And again, a quick double check allows us to realize that that's exactly what we expected. So what we take away from this particular question is the overall method as to how to find the equation of a cubic graph when given the turning points, a turning point or actually sometimes both turning points. What we're going to do is we're going to make sure that we know that we're going to solve simultaneously. We're going to set up the equations, equation 1 from the original equation, where we can substitute an x and a y coordinate in there. Equation 2 is where we use the derivative, where we can substitute an x coordinate or the x coordinate of the turning point and 0 for the derivative, because the derivative is 0 only at the point of the turning point, right? As long as we keep that all in mind, then we'll be okay for dealing with questions like this.